Cool. So I did attempt this morning and I hit a bit of a roadblock. So I'm just going to cover quickly what we're doing and why. So in front of me here, I have 3 stepper motor drivers. They all look fairly similar. If I can get it focused. Second. There we go. So this, this is one of the drivers that came out of the machine, out of the 3D printer, and this one got damaged, I believe. Some of them got damaged. There are 4 of these, and I believe some of them got damaged because the fan that was blowing air over them stopped working, and you can see they've got quite a big heatsink. So these are stepper motor drivers, and what they do is they basically take the electrical signals in terms of direction and speed and all those kinds of things, and they turn that into of the actual motors. So they do a lot of calculations in terms of micro steps, essentially telling the motor to hold positions between its full steps. So the motor turns in, stepper motors you turn in 1.8 or 0.9 degree steps, but then you can do what's called micro stepping in between that, where you partially magnetize magnets inside the motor, I guess, to make them hold position between the full steps. So these that came out, I can't remember the full name. Actually, let me look them up. So here I've got a little spreadsheet. LV8729s. These are what came out of the printer, and these do 128 microsteps. However, they're not quite as good as these drivers, which are from different manufacturers, but use driver chips from a company called Trinamic, which are much more silent motor drivers. So this one does 64 microsteps, so half, and this one does 32, so a quarter of the previous one. But overall, hopefully these should be an upgrade. They should be much quieter, a bit more efficient. This one I'm going to use on the extruder motor, and then 3 of these for movement. Now, in the previous stream, I got that the wrong way around. 3 of these for movement. These for the extruder, if I didn't say that. In the previous stream, I came across a bit of an issue where this has 2 extra pins here. Okay, and look at the close-up board here. Those pins interfere with these capacitors here, so I can't actually plug these in. I was thinking when I ended the previous stream that I would need to desolder those pins. However, getting these mixed up. However, I realized that at the same time as buying the drivers, I bought some of these, which are, pull one out, they are called, get that info there, silent step stick protectors. What they are essentially is a bunch of diodes. So a diode is like a valve, if you know a valve in terms of plumbing, allows fluid only to go one way. Diodes are essentially the same for electricity. Put these between motherboard, put that way, and your stepper driver, right? Plug those in between. And the idea of these is that they prevent electricity flowing from the motor when it's not powered back into the main board. So I did actually realize that when I move things about manually on the printer, sometimes it, well, not sometimes, if I move the axes manually quickly enough, it will power up the board. Like I'll actually see the LED come on the main board, board here, which is a little bit scary. So these things allow us hopefully to counter that, so they will stop any current coming back. But what they also have an added benefit of doing is they allow us to plug these in without the 2 pin interfering with the motherboard, because they're not kind of carried through. So, I mean, the soldering quality and things on here is not the best. Get a close up of that on this camera. Let's do it. Soldering quality is not the best, as you can see, but hopefully they do the job. I'm just going to use, like I said, to raise everything up. Another slight concern I have is that over here you can see the fan doesn't blow directly onto this stepper driver. So I obviously don't want to have the same issue as before, especially when the heat sinks for these steppers are so much smaller than the ones on the old steppers. So I might need to make some kind of fan shroud. Like I could 3D print something, but I don't have a working 3D printer right now, hence this video. So I might just make something out of cardboard. It isn't the most fire safe thing, but just a little duct that will direct air in this direction as well as straight ahead. Hopefully that should do it. But for now, for testing, hopefully there's enough airflow for me to get these installed and tuned, which is the next thing we're going to do. So first thing I'll do, confused about this again. First thing I'll do is assemble all of these with the protectors, and then see where we go from there. So I've got 3 of those, 3 of those, not that. This one. Yeah, and I'll just show you on here. Actually, focus back. Using manual focus here, really good. Automatic focus leaves a little bit to be desired. So they each have screws. You can see they're in slightly different positions on the 2 different types of board. But those screws are important. That's how we're going to adjust a certain voltage that we measure, which will decide the amount of current and essentially power being fed to the motor and therefore heat being put into the motor, and we want to minimize that while getting the most performance out of the motor. So that's the aim of tuning them, which we'll come on to once they're installed. So first, let's just assemble all the bit fiddly this interface. Okay. Got to take care of direction as well. Obviously, make sure they're the right way up. Thankfully, all of these have labeling on them. Do the focus thing one more time. That's the wrong slider. On. They have labeling on them so you can see which pin does what. So there's a ground here on my thumb, then the step. And also, if you look at the big Tree Tech ones, these 3 holes at the top where these 2 extra pins are, these 2 extra pins line up with those 3 holes on the top, and you'll see on the underside here, there's an actually 3rd hole there which lines up exactly. So these are fairly easy to line up. Also, they say top and bottom on them. Top, bottom's on the, yeah, bottom there. So let's plug these in. Slightly confusing on this one that the writing's actually upside down. So this is the right way up. The top is the top here. Top of the screen is the top here, but the writing's printed upside down. I hope I'm reading that right. I hope that's the way it is. But the ground is on the bottom left. So that would make sense. Enough talking. Let's get these together. Two. Okay. Or I'm not sure how useful this will be on the extruder motor, although I guess sometimes I do pull filament through with the motor unpowered, so potentially useful. I guess when I'm doing when I'm unloading filament, that might well be something I do instead of waiting for the motor, just yank it through the machine. Okay, so now switch over here. I'll plug these in. Now the machine's completely off right now. I've also unplugged all the motors and labeled them because I would not remember where they go back. So way up this goes actually. Round bottom right, so there. Because the pins are a bit bent, I'm making sure that it's not like super tight there either. But hopefully it's okay. And the other, so that one needs to go there. That's the extruder mode. Then the other three don't really matter. They're all the same. So I don't need to change any of these configuration jumpers, I believe. These configure how many micro steps. So I said these two 64 and these two 32. I think having all three jumpers connected here means that you'll get the maximum out of both of these boards, but that varies depending on which boards you've bought. That one's not going. Okay, it's not super happy with the way that these silent step stick things sit in. They're not very secure because the pins are so thin compared to the ones in the actual driver boards are much thicker because they're so out of line. But you can't really see it on camera, but they are razor thin, and I'm guessing that's why they're slightly bent as well, just to make sure that they kind of clamp into place a little bit, a bit more friction. But we'll see how it goes. Makes a good enough connection not to be an issue. 3, 1. Fourth one I'm putting in. Most out of alignment one there is. Horrible scratchy sounds when I try and plug it in. And okay. If I had time and patience, I would resolder all of those little boards, but I don't have either of those right now. I am going to do though. I'm going to just pull this out and seat. Try and seat that independently because it's giving me a lot of confidence. It sits down. I'm not sure if it's bottomed out in the socket or if it's, I don't know. Okay, I think this might actually be getting enough airflow from the fan. So the fan's obviously round, right? So in the center portion of the fan, there's definitely air coming to this area. The question is, just because this is sitting slightly above center, the question is how much of that air is going to come. I'm going to swap this one and this one because the heatsink on this one is placed slightly right to that one, so it gives us a bit more chance of airflow getting there. Okay, so before I go to the next stage, I'm just going to check on the stream a second. The stream's on private. Amazing. Okay, change that. Click. Sorry about that. Hope. That fixes it. Check again. That's a bit of a fail, isn't it? Check in incognito just to make sure. seems to be live. Okay, so I'll just go into, for the benefit of anyone who's, well, there's no one just joined yet anyway. Once more people do join, I'll do a little bit more of I'll repeat the intro in terms of roughly what a stepper driver is, etc. I'll try and keep an eye on chat as well at the same time. Okay, so now that these are plugged in, we need to tune them. So motors are unplugged, which they need to be, and we're going to need to turn on the machine and get a multimeter as well. So first thing I'm going to do, after checking that they're seated properly yet again, do seem to be, just going to plug in the printer to make sure that nothing blows up basically and that the fan still works, which is important. So that's plugged in and yep, fan is on, and that's a lot of air actually coming out of that fan. Fairly powerful fan, so yeah, and it's definitely reaching this driver, which is good news. See the Wi-Fi module failing. Oh no, connected to Wi-Fi. It's going to go into the menu on the front of the printer here. Can't see. It wasn't connecting to Wi-Fi before. It is yeah, it's connected. That's nice. That's good news. Okay. Now we've got to tune the drivers. What that means is we've got to measure a voltage between, if I come here, you can see here, there's a bunch of these formulas. These are simplified versions of the formulas. This is like a full version. Don't ask me to solve it. I don't know how it works really. All I know is that your stepper motors, which are, back to the close-up, stepper motors are these things, right? So I have 3 of them on this printer. There's one back there, which you can't see, one here and one here to control movement. That's 3. And then there's a 4th one to control the filament that runs through the printer. These have a set current that they're optimized to run at. Now, I don't know the set current for these, right? I tried to look up the model number that's printed here. I couldn't find what the current was that they're supposed to run at. And it's important to know that because you want to run as much current as you can through the motor without stressing it too much, generating heat, which is going to damage it. More current you put through it, the more powerful it is, the faster it will be able to accelerate, the more strongly it will be able to hold its position. So that's what you want, right? Now, seeing as I don't know the current on these, all of the different stepper drivers, when you buy them, come with some reference material that tells you how to convert that current into something that you can measure on the driver, which is a voltage. You measure between the screw that I pointed out earlier and ground. Measure a voltage, you plug it into this formula to say, if I want this current, it should measure this voltage. So what I did was I measured on the existing drivers voltages, plugged that into the formula backwards and came up with a current figure, which comes out at about 0.75 amps. I have no idea whether that's right or not, or whether I did the maths right, but hopefully it's kind of right. And then I can plug that into the other formulas for the other steppers and work out what the voltage should be that I measure. And now the extruder motor on here is a bigger and more powerful motor than the axes, than the movement axes. But I'm going to set them all to the same, right? So I'm going to set steppers and the axis steppers and the extruder stepper to about 0.75 amps. So for the 3 drivers on these 3 drivers, axis steppers, that works out to measuring a voltage of 1.193. And on this one for the extruder, it works out to 1.114. So there's a little trick that I saw from another YouTube video, which is to use these. I had to buy these, but I'm sure they'll come in useful. Alligator lead test leads for a multimeter. So You can clip one of these onto a screwdriver, and then as you turn the screw, you're measuring the voltage through the screwdriver as well, so you don't need to keep making an adjustment, testing, another adjustment, testing. You can do it all live in front of you. So that's the plan. And obviously ground will just have to hold the probe on there. So let me get my multimeter, and hopefully I can set it up in a way that it shows on the video as well as being readable for me. So this is my multimeter. It's currently set to voltage AC. I don't know why it defaults to AC. I was going to say I don't know who's measuring AC as the main thing, but electricians, right? That's kind of their job. Should probably get a screwdriver as well. Need to be very careful about shorting things out as well. In fact, while I'm setting up, I'm just going to turn off the printer. Seems fairly readable. It's not going to move about too much. And try and get a screwdriver that works well on these boards. So this is my toolkit of small stuff. Hopefully. Yep, that seems to work. And let's try it on. Okay. Yeah, well, that's not really turning those screws. One of these steppers did come with a screwdriver. Let's see if I can find it. But it's a cross and the rest are a star. Okay, that works pretty well actually. So we might go for that. To here. Okay, if I sinks and things away. Okay, so plan is, and I'll just do this with rough to start with, just so I'm doing the right thing. Plan is to take that screw while holding the probe over the ground wire, which is this one, and measuring the voltage. And the numbers that I need are up on the screen in the bottom right. So for these, I need 0.193 volts. See how it goes. That's very sensitive. 1, 2, it's very, very sensitive. It's got a bit of backlash as well, it seems. So turn it one way and it shoots up, and then turn it the other way and it does nothing for quite a bit of rotation. 0.1, 6, 2, 0. Yeah, look, I'm going back now, not going down. 1 point. Wow. When I looked up the instructions for doing this, they said that it was a sensitive adjustment, but that's really a lot more sensitive than I was expecting. It does have a big range, but think maybe I might just go 1.2. Not able to adjust it finer increments than that. 0.19918. Still, that's going to shoot up to 1.2. That's annoying. And I know it doesn't make that much difference in terms of the 3 decimal places, but being a perfectionist right now. Apologies if there's a chat message. I'm kind of glued to this right now. I will check them in a second. I've got this done. Oh, had 1.19 by. Maybe if I go all the way out, there we go, and then back. 1.193. That's good enough. 194. Maybe that's the strategy. On to the next one. Get this. That's measuring nothing. Cannot be right. 3. Go down. One 8. Close. 1 8. 2. Very close. Yeah. Maybe part of it is the multimeter being slow to update and not backlash. It's more not being patient enough after each adjustment. Big change that I just made, and it had no. Might be due to conductivity through the screwdriver as well. So close. 0.193. 11. Gonna untouch that and touch it again. See. Yeah, still 1.16. Should I leave it there? Should I say 1.196 is close enough, or should I? Yeah, I'm going to say that's close enough. Throw it way out of whack if I try and be any more accurate with that. Okay, so this one is to come that way. 2.193. Bang on. Happy with that? Okay, now this one is a different model. So this is the TMC2209. This needs to be 1.144. What I'll do after I've done this is I'll get a normal test lead on here instead of the alligator clip screwdriver contraption, and I'll just double check them without, or trying not to adjust them. Good vantage point. See, where it's very easy to kind of short out the drivers here by connecting the wrong, touching the wrong pins. So, okay, so here I need 1.144. Being 1, 2, wrong way. 5. That'll do. Okay, so let me get a normal test lead on, and we'll double check all those. And also, this shouldn't have worked if these were plugged in the right way around. Fairly confident that they're all the right way up, so not warm at all. I think we're good in that point of view. So let's check that, and then I want to test kind of moving the motors around and seeing if it's letting any current through, if these protectors have worked or not. First, let's just double check these measurements. See it? See, that's visible. I mean, the third decimal point's kind of useless because, as you can see, it's flying all over the place right now. Okay, so we got 0.193. Perfect. What did I say about shorting? Touched the wrong pin. 1.196. Not quite perfect. 1.189. Again, not quite perfect, but it will do for now. 0.15. 0.17, 0.146, and I wanted 1.14. I think those are close enough for now. They're certainly a lot closer than, if I take you back to certainly a lot closer to each other than variants that we saw, sorry, here, between the initial install. So these are movement motors, they should all be the same, but we've got from like 0.84 way to 0.77, so certainly better than that. So I'm going to turn off the machine again. What I want to do is, you won't be able to see this unfortunately, but I'm just going to move. I'll show you here. That knocked the camera. Bad. Just trying to bring the actuator into frame. That way. So this is the print head. See there? It's disconnected these two that I'm wobbling right now, to actuators, because they hit the camera. But if I then move, yeah. So if I move the rod that was not the rod, but if I move the so these are the ends of those actuators. They connect to some magnetic ball joints on a belt connected to the motor. So these belts that you see here and here, there's another one there, which is the one I'm moving. Connect to belts, and then they move a pair of ball bearings or a pair of joints that are magnetically connected to these, and that's how the printer moves. I move that up and down. See that those diodes are doing their job, because before there'd be a green light coming on here, meaning that it's spreading power through and it's on. Thanks, Putul, welcome. And now, I don't know if you can hear that moving up and down, but no matter how fast I do it, no power's getting through. That's a good sign. And now, plug this back in, and we're gonna do some adjustment. So let me switch to the other camera and tidy up a bit, and actually take the opportunity to explain what's going on, seeing as I started the video on private and no one saw the beginning, apart from me, but there's no point in me seeing it because I'm doing it. Get these out of the way. Okay. Okay, so what we were doing was we were just tuning these stepper drivers. So these are what converts signals from the main board of a printer into to the actual essentially AC alternating current frequencies that the motors need in order to run. And I was talking at the beginning about how try and focus here. Now these, which came out of the printer, there are 4 of these. LV8729. I don't know that off by heart. I read it off the screen. These LV8729 drivers that came out of the printer are potentially damaged. You can see I've labeled them according to condition in case they're not. But I think they overheated when the fan failed. So I've replaced them all with ones that are not quite as accurate, but hopefully better in all other regards. And what we were just doing was tuning them by using a multimeter to just set the voltages to some stuff that I very roughly and hopefully accurately worked out according to some formulas that are here. Obviously in a Notion database, because why not? Okay, so let's get the zoom back. Get those two mixed up. Okay, let's tidy up a bit. Get the printer into frame in some way that you can see it. Put that there. Time is 20:56. I'm going to go for about another 10 or 15 minutes at most, I think. Okay. I'm not sure how this is going to work with the camera perspective, but that almost fell off the desk. Yeah, you can kind of see it actually. That's going fairly well. If I move the power supply, that's a bit worrying. Stuff that came out of the power supply, black hairs or something. Like, I think it's probably just cat hair that I seem to carry around with me everywhere, even though I haven't seen my cat in months. Okay, plug that back in, and I'm trying to see if you'll be able to get a good view of what's going on. So right now, probably want to see the screen. I turn on the printer, screen turn on. And now what I need to do, due to the micro stepping difference that I spoke about, can't see the drivers here actually. Can you see them? Yeah, okay. So these three have half the micro steps, and this one has a quarter. I need to go into the menu here and reconfigure that. Configure the micro steps. So if I go to settings, motor, I can zoom in here. Benefit. I've zoomed. Sharpness, that's not messed with some camera, haven't I? Don't know what it is. That's the most we can go. That's the most we can go, unfortunately. Okay, so if I go to settings, motor, step value. So the x-axis step value is currently 640, and so is the y, and so is the z, obviously because they're the same. And we've halved that from 128 microsteps to 64. So I need to halve 640, which is 120 here, 20, and then the extruder axis, which I kind of had to work out by a bit of trial and error when I upgraded the extruder with a geared one, and it went up massively because the gear ratio is 3:1, but then the input gear was different as well, so I think it was about 4 times the amount it was before, which may have been like, I don't know if the machine could cope with that, probably, but it's currently 3,180. Divide that by 4. This driver actually is the one that I modified on the soldering stream to put it in the more powerful, less silent mode. So 3,180 divided by 4, 9, and I'll need to retune this. It'll be easier because the numbers are a bit smaller this time. But it says that value 180 divided by 4 is 795. turn it off and on to make sure that that value is set, and then essentially just keep my finger poised over the stop button while I try and home and move the machine and see if it works. To step value, yep, that's all there. Okay. So this home button should make everything return to its origin or 0 position. So hopefully everything up. You can't quite see it from this camera angle, unfortunately. I click home. Nothing happens. Nothing happens because the motors aren't plugged in. That's something I forgot to do. So let's do that. Yeah, I forgot to do that. So I labeled them like I said because I was not going to remember to goes where, which connector goes where. 2 E, which is that one. I was pressing the home button and I was like, why is nothing happening? First of all, why is nothing exploded yet? That's a good thing. Secondly, why is nothing actually happening at all? Which is not so good a thing. I'd much rather not moving at all than explosion though, so. It should say number 1, which it does. And that's going to be to there. Sorry, like the camera angle is terrible for this. I think I'm sitting here thinking that I'm showing you stuff when I'm not really. Just plugging these into the board. These are all the motor connections. It's the final one. Okay. They're all in. 1, 2. The printer, and I think most printers, even though they're Delta printers, X, Y, and Z, they don't obviously run the X, Y, and Z axes because that's not how a Delta works. So I've just labeled them 1, 2, 3, and E for extruder. Hopefully this time, no explosions once again. Switch back to on. I'll wait for the Wi-Fi to connect just to make sure that's still working as well. Doesn't want to connect right now. It's weird, it's temperamental, that Wi-Fi chip. Okay, so now, hopefully, check these values while I'm here actually. Those look correct. That was super quick, but then it didn't really do what I wanted there. Try that again. That did not seem to go exactly to plan. Again. Trying to run this motor, and it's this one here. It's like struggling, making that horrible vibration-y noise, but then it's fine. I don't know if that's like a first-time tuning thing or if that's meant to happen. A bit scary. Maybe it's because there's not enough current and I got those formulas wrong or something. Let's try movement. Say, go down on Y. That was not useful. Oh, is it a direction thing? A direction thing. I sound like a professor. Thanks. We're going up. This is not right. This printer thinks it's something else. Okay, that's working. X-axis is kind of working. Ah, Y-axis is working. Z-axis. Yeah, that's working. That's not 1 millimeter though. Telling it to move 1 millimeter increments, and that's. See if I can get this into frame. There you go. You can see it moving. Those are definitely not 1mm. Let's move like 5. Why is that? TMC2209 should be 64. Oh, okay. I configured this driver wrong. Cool. Back to the drawing board. Back to... Okay, so let me show you what I've just seen. Probably check the 22.5 as well. Yeah, let me do that quickly as well. Okay, so I said that the TMC2209 configured for 1/64 was supposed to be high. Here it says low-high. That applies to the Lurch version of this, which I don't have. I have the Big Tree Tech versions. Probably check that as well. Tree TMC2209. Check documentation of it. That's not the right documentation. Manual. Right, that's probably far too zoomed out for you guys. Okay. Configuration setting. MS1. CC ground. I don't know what that actually translates to. That's a bit confusing. What that translates. Gone. So ground, I understand. Okay, let's unplug these and just laying them out on the desk in the order they came out, just to try and get sure that go back in the right place. Although it doesn't really matter for these three, but it's easier that way. Okay, so back to here. So what we're talking about is these jumpers here. And the TMC, TMT 2. This is the product page for the 5. Okay, so that's correct. VCC, VCC. Third one doesn't matter. It's 1 MS2. I wonder if those are labeled on the board. If not, then I'm going to go to so this is the documentation, not the documentation, this is basically the sales page board. Yeah, that's not what it looks like. It's vertical, horizontal. That's probably an MS1, MS2, MS7. Don't know which one's MS1 and which one's MS2. Quite confusing. Pull all of them out for now. No, they were all which means high. I have a tool for this actually. Get a tool. Have these self-closing tweezers. They're really helpful. They bring that closed. Don't need to just kind of stay in place. I go back close up. Just kind of stay in place, and then you can squeeze the bottom portion, stuff like this, out really easily. Right, let's see if there's any markings on that board there. Not that I can see. My issue is I don't know what's MS1 and what's MS2 and what's MS3. But I know that I need to go CC ground, which would say to me, why has it got MS2 first? Sorry, I'm not even sure. There's MS2, MS1, CC and ground. Very confusing. Kind of a good thing that I'm doing this on live stream because I can look back at it. I'm going to follow this one. I'm going to follow what alerts say for everything. And then if it's wrong, then do something about that later. So I think the 2225 I don't need to worry about, right? Because that says CC, VCC, and then assume that means doesn't matter. So that one's good. These, low, high. This one technically is saying high, low. Get scared. Let's go low, high and see what happens. So 1/64. Low, high. That means we just need them. That would be good because I don't need to worry about the order either. It's just the one in the middle that's low. No, it's not. Yeah, the one in the middle is low, so that's not connected. High is connected. Okay, so I think I just need to pull out this and this on the first three. Let's give that a go. Ow. My finger there. Okay. Now plug everything back in. I wonder if I got the orientation of these wrong, but then I'd expect it like either not to work at all or to explode in some kind of fiery ball, which did neither of those two things. Get those wrong. That one goes there because I think it's a bit further to the right. Actually plug it in. Then final one. Okay, let's try again. Second time. That's better. very smooth, gets to the top. Yeah, happy with that. Now if I tell it to move Z, tell it to move down by, I'm not even showing you what I'm doing. Go ahead, there we go. If I tell it now to move by 100 millimeters down in Z, that's seeming like it's working. The easy way to check that, I guess, is with a ruler. So if I get a ruler and just measure how much this thing that you saw move its frame is moving up and down, should be good. So here, 100 millimeters. Apologies that you can't see this. Try and sort out a better camera views for this next time. Okay, move up, and yeah, 100 mil, perfect. So that's done. I think the only other thing that I would want to do is test the extruder. But to do that, I need to, well, do I want to put these jumpers back to ensure they have a safe place to stay? Let's do that, and then I'll put a temporary cover on top of this so that we can test the extruder. And then level it and a test print. Might have to end the stream soon though. This is good progress. Glad that I streamed this, because without a video reference I would be very confused at some point in the future as to why things were configured this way. So, yeah, okay, let's pull these back off. Pull these back off. Just gonna essentially store these little jumpers so that they're not shorting any pins, but they're just kept here in case I need to come back here in future. I know that they're here. Like I said before, I'm not really happy with how loose these protector things feel in the socket, and how I think maybe the legs are longer than the actual depth of sockets or something, because they sit kind of proud. They don't sit level, but they do the job that they do, and they saved me from like having to desolder a bunch of stuff today. Desolder 2 pins. So can't complain too much. I guess they are just like bunches of diodes, so if they do come loose in some way, hopefully won't thin air. So I haven't changed any configuration by putting them back in, unless something is seriously wrong with the way that the board is built. Okay, so the final time now, hopefully. Quite easy, thankfully. Getting used to it after seated times. 2 and in and secure. Stay up. Cool. Okay, so wondering if I should do the extruder test now. Like I'm fairly sure the extruder should be okay, because it says here, right? Not there. It says here, TMC2209 TV. Doesn't matter. So that's what I've got set. It should be 1/30. Fairly confident with that. I think I'm gonna reassemble, do the bed level, then test the extruder. See, there's no, because the cooling's what I'm worried about. Once you've heated the hot end up, it takes a while to cool down, and yeah, okay, let's do the heating, the test, and maybe extruder tuning. Maybe that's another video. Maybe extruder tuning's not a video. going now. Yeah, okay. Let's get it back together, I think. Let's get the printer back together, and then the next thing will be another video. So there is a plate that goes on top of here, like so. So that just gets screwed in, and the cable for the hot end comes through like so. And then there's the actual bed that comes on top of that. So I'll do that off camera. It's fairly boring, so reassemble off camera and then do some more testing. But compared to this morning, this went pretty well. Counted a couple of roadblocks, but managed to get through them this time, so I'm quite happy with this stream. And I am going to Assalamu alaikum Burhan. Nice to see you. Thanks. Yeah, nice Monoprice printer. Yeah, I think I'm going to end it here, and we will do the rest another time. Maybe the live streams don't really work for prints, but maybe I'll upload a video, like a time lapse of a test print or something, if everything works. Like I said, the rest of this is fairly boring. So thanks for tuning in, and see you next time.